madam. Ravina madam.
Yes, madam.
Yes, madam. We can start now. Sir, shall we start, sir? Kotari, sir.
Sir, good evening, sir. Saila, madam. Kotari, sir, unmute, sir.
Yes. Good evening to all. I welcome Dr. K. Pravina ma'am, Associate Professor, to introduce our today's resource person. Ma'am, please.
Thank you, Saila, madam. Words can inspire, thoughts can provoke, but only action truly brings you closer to your dreams. With this thought, let me start today's sessions. Most respected resource person of the day, Professor Aji Kotari, Director of the IQAC, and learned participants. Good evening to all. I take pride in introducing today's guest speaker, Professor Kotari. He has completed 26 research projects, 250 papers have been published in the journals of repute. He is the editorial board member of many journals, to name a few: BRICS Journal of Educational Research, E-Reflections, Education at Crossroad. He has published 20 books. His books, Mathematics, book Research Methodology, published by Institute of Distance and Open Learning, University of Bombay, is very popular among research scholars and teachers. He has translated 2 books. He is member of the various academic bodies. He has served as resource person in nearly 500 workshops in service programs, and he has published 85 papers in various national and international seminars. He is a recipient of many awards, to name a few: Ramanujam Award for the Best Mathematics Teacher, Best Teacher Award from the Governor of Gujarat in 2015. He is also a member of many reputed academic bodies. He is a member of the Research Board of Advisors by the American Biographical Institute since 2002. And when he has served as the Vice Chancellor of Veer Narmad South Gujarat University in Surat, he has introduced 19 PG courses. Such a great academician, stalwart in the field of mathematics education, is here to explain to us about the sampling in research methodology. On behalf of IQAC, I welcome you, sir. Thanks for accepting our invitation and being with us. The platform is yours.
Thank you. Good evening, everybody. Yes, is it audible?
Yes, sir.
Yes. So nice to meet you. Thank you, madam, for nice introduction. And I'm happy to see all participants here. Well, friends, it is on sampling. So I would like to ask you a few questions, if you can respond to. The sample size depends on what? Sample size depends on what?
Population.
Yes. Sample size depends on what? Question number 1. Yes, no answer?
They are giving it in the chat box, sir.
Yeah. If you speak, it will be all right.
Okay, sir. I'll unmute them. Okay, sir.
Number of respondents. But who will decide number of respondents? Second is population size. So who will decide population size?
So participants can unmute themselves and speak now.
Acha, they can't speak. Okay.
No, now I am enabled, sir. They can speak now.
So research objective?
Somebody said research objective. Somebody says equal opportunity. Researcher.
Based on the objectives, the researcher will do the sampling.
Researcher will do the sampling. Okay, I am not getting the correct answer. Whether it is a research objective or population size or respondent, technical meaning had not come. Okay, fine. Second question. What is statistic? S-T-A-T-I-C. Statistic. S nahi hai. S-T-A-T-I-S-T-I-C. What is statistic?
It is applied on the
It is a
sample.
collection
Sir.
of
It is
Samples,
obtained
sir.
sample.
it is a collection of data, sir, organizing, collection, organizing, interpretation, analyzing the data.
Somebody has used sample parameter. That is not a correct word. Sample parameter. Okay. What is parameter? Okay. Statistic.
Collecting the data,
Data of the study.
collecting the data of the samples, what is the particular object, we are collecting the some data and the values we will put it to the one table and calculated the estimated values as significance difference if you find or not, that the shape and the result will be give the statistics.
Estimated value according to you will be a parameter.
Yes sir, yes sir.
You are covering all the syllabus. Somebody said inference and all other things. Okay. So statistic and parameter. Any idea about standard error of mean? Somebody has given correct answer for statistic sample characteristic. Good.
Thank you sir.
Standard error of mean.
This is the standard deviation of means of all other samples.
Okay, which are all other samples? Because we
The
work
mean taken from the population, sir.
mean taken from population. The standard
Population.
distribution. Okay. ठीक है. That's a good knowledge. चलिए. Then we begin. In between, if you want, you can ask also. So, I will begin from a very small example that when we wanted to know something, remember, when we wanted to know something about the people. Somebody is not mute. Sample distribution. Now, okay, somebody is microphone is on. So we begin. Okay, mute to all now. Okay. So, when we wanted to know something about the people, remember, muting will be a bit difficult. Huh? You have to answer also. When we want to know something about the people, about the events, about the things, what do we do? Someone can unmute and answer for a second. When we wanted to know something about the people, about events, about things, what do we do?
We have to select one questionnaire to what we need, we're expecting from the people about a disease or living style.
Somebody said we have to collect data. Somebody said we have to survey. Okay.
Survey means that
Get feedback, sir.
the questionnaire, the proper questionnaire will give the proper color data.
Okay, so entire process you have highlighted about that. Here what we do, we considered some people whom we know. We considered some people whom we know. I wanted to know what is the quality of a course now going on in Department of Education, Annamalai University. Then I wanted to know what is the quality of.
Go to that department and do a survey.
You will do a survey, but whom do you contact for survey?
The people who are from Annamalai University, the educational department.
Who are there in
Concerned.
Annamalai and those who have attended that particular course. I don't know what to call this course is.
Attended course.
Okay.
We will collect the first. We have to meet first the HOD of the department and what we are offering the courses and what is the result they are getting. What are the credentials about that department?
I simply wanted to know, you wanted to know quality. Whom do you consult? Right? So naturally,
Students who have completed and are still going on.
Students who have attended this course. Okay. So to whom we know, rather, to whom we know, we will be doing this. Sometimes our attitudes, then our knowledge and our actions, they are also based on what? Our attitude of the people. Oh, this guide is not good. Oh, this head of the department is not good. So on what base you conclude this? This man is negative.
Past experience, previous knowledge.
Experiences. Okay. Or
From perception of the
perception.
Okay, good.
perception builds with the survey. So
Survey.
whatever they say, we collect it and we perceive.
Okay, you have studied a lot about research, it seems. So, rating with other experts. Okay, fine. Now, third example, a person's opinion about a bank. A person's opinion about a bank. There is a bank nearby my university office, and I am a customer there. So what will be my opinion? Opinion about bank, then how will you get the opinion about the bank?
My experience comparing the other services of the bank.
Services.
Okay, services provided by other, but other you are having only account here only, then what you will do?
Customer satisfaction.
Others experience, okay.
Customer satisfaction.
It
Similar
depends on the manager of the bank. You interact with people inside the bank and you will come to a conclusion if the about the manager and the staff, and then you tell how.
So ultimately it is the customer satisfaction which matters, not the view of the banker.
Very, very good word. You are from management faculty?
Service
Yes.
provided by the bank, sir.
Yes.
Management faculty talk about this customer satisfaction.
Thank you.
Anyway, chaliye. Then about shop also, about a particular shop. You show there are 3-4 shops in a line, but in one shop, that many people are standing in queue, but remaining 3 is sitting idle. Right? Similar is the institution. So generally what happens here, it is our 1 or 2 encounters we sometimes conclude. We conclude with 1 or 2 encounters. I will give a simple example of my experience during a student life. Once I went to a bank at 10:30. I'm talking about almost 1974. At the time, timings of the bank were for 11 to 5, a very general time in Gujarat. So the peon said that aap aa gaye, you had come, but bank will open at only 11 o'clock. I said, I had a class at 11 o'clock. I will not be able to come at 11 exactly. Then one clerk was there. So that clerk said, okay, it's better. You fill up your withdrawal form, sign it, give your passbook and everything. What time you will be free? He said, I will be free exactly at 2:15. I had half an hour break. So you come at 2:20 and I will give you the money. So I was so impressed and I carry a very good impression. So here what happens that sometimes our impression is only with 1 or 2 encounters or 1 or 2 episodes with a particular institution, with a particular bank, or with some guide or with some head of the department, but which is, you can say, which will differ. Those who are working the several years in the bank, and your opinion perhaps differs. Suppose a visitor comes in India and spend few days and talk something about India. And there is another gentleman, sociologist, comes in India, stay for a year, travels widely, meets people. What is his experience?
Just a bird's eye view.
Okay, good. So here what we will say that our conclusions means conclusion of a person who stayed 1 year or in the India and passing some judgment, and one who stays only 15 days and passing the judgment, things are different, opinions are different. So here what we do in first set of example, we try to conclude from our limited experiences. We try to conclude from our limited experiences. I had one experience and I said that that bank is very good, right? Sometimes I have left my office and one student had come that, sir, I need your signature. I will again open the office and I will sign it. Then he will carry a good impression. But if I will say that, okay, it is already now, the office is closed and Pune has also gone and I will not reopen and I will not do that because I have to put a stamp also, then he will carry another impression. See, these people are not student friendly. They are not helping. They are not encouraging students and a number of things. So our conclusions are with a limited experience, and sometimes whom say nowadays always people speak 2 sentences. Politicians are corrupt. Everybody and anybody will say politicians are corrupt. Second thing, sense of moral values has gone. Distortion of sense of moral values. This we
Rightly said, sir. You rightly said.
So this is also from 1 or 2 encounters or 1 or 2 experiences with the people. So here in this first set of example, we conclude with limited experience. So when you go with a limited experience, your research and your conclusion will not be reliable. Only you can say first-hand interaction or hearing others. But here we never think of that who and what type of persons are interviewed. Who and what type of persons are interviewed. Who? A person is quite negative. Once in 1996, we started MPhil at our department and we got some 6-7 students. And then it so happened that our enthusiastic staff member taught them like anything, and they could not complete MPhil for 3 years, which was almost a 3-semester course. For them, they took the, you can say 6 semesters. As a result, what was the impression? Are you going for MPhil? Don't do here. Don't do here. This is only experience of 2-3 people. So our limited experiences and whom we know. And how many interviewed, that is also very much important. So these 3 questions we are not addressing here. Whom we have interviewed, what type of person he is, negative, positive, and how many interviewed. So our conclusion here in first set of example is bit not valid, not reliable. Now let me take second set of the example. Have you gone for purchasing of wheat? Gehu. You people take only chawal, rice.
Mostly, sir.
Yes, sir.
So when we go to purchase the wheat, that is my experience, there is a bag. That bag contains 100 kg of wheat, or 100 kg of rice, whatever it may be. And then there is some sharp instrument. The businessman or the trader will put it inside, and some wheat will come outside. Some means only 50 grams will come outside, and you will judge the quality. And that is up to certain extent, you can say that is 100% reliable. Entire bag, remember now, entire bag contains 100 kg of wheat. And with that instrument, sharp instrument, he puts it inside and 50 grams of the wheat will come, and you will see, examine, and you will conclude that, okay, that's fine. First example. See, second, a tea tester. You go to, I think, Tamil Nadu also tea testing will be there. In Meghalaya also it is there. In Assam and Guwahati also tea testing. So tea tester will be trying different brands of a tea. So he will not be using 1 cup of tea for one brand. Otherwise it will be stomach and everything will upset. But within, I think, a spoon of tea, prepared tea, he will be able to conclude the quality of the tea, right? Not entire, and that is there. Even if we say that somebody is offered a cup of coffee, and if you are asked for the sugar, you will not say that let me enjoy and after that I will conclude. No, you will say that no, there is less sugar. You can put one more spoon. So a tea tester, second example. A third is a technician taking the blood test. He has taken from this hand only. I said, no, I am a research man. You take from this hand also, this leg also, then conclusion should be there. Then he started laughing. Sir, what are you telling? I said, yes, we have to generalize the event. So then he said, nothing doing. I will take 10 ml of the blood from your left hand, and whatever test I wanted to do, that is reliable. So this is third set of third example, technician making a blood test. Fourth, a cook is checking. Now we have a pressure cooker. Otherwise, earlier we used to prepare rice in a pan, and which is closed, not permanent, closed like a cooker, but you can check it. So what cook will do after a few minutes, he will only check few grains of the wheat, only few grains of the wheat, and he will conclude that entire what in the cook pan. So you've seen now in second set of the example, I have given you example of a trader examining the wheat, handful of grain only, a wheat or whatever it may be, grain from the bag, entire bag of 100 kg, a tea tester testing different brands of a tea, a technician making a blood test, and fourth, a cook or one who cooks the food, checking few grains only of the rice of the pan and determine that it is cooked or not. But here in second set of the example, your conclusions will be more reliable. Why? Conclusions will be more reliable.
The sample taken is the representative of the total population, or you can say homogeneity.
Still, we have not gone for the sample, but whatever the material is there, that is well mixed. Whatever the material is there, that is well mixed. You say it is homogeneous.
Yes.
And that's why even 50 grams you have seen, that is you can say it's a representative. It represents all the characteristics. Okay. So this is in second stage, what we are using is the correct sampling. Correct sampling without, still we have not given the name. Now 2 words, population and sample. Suppose you wanted to study the problems of Annamalai University students, and you say that there are 25,000 students in Annamalai University studying in 2020 to 2021. 25,000 are studying in Annamalai University during this year. I am specifically mentioning year also. And you want to study their problems. Problems, we can say, whatever, that is another issue. So what do you call this 25,000 as?
Universe.
Now see, these are two words coming, universe. Then one more word is also there, universe. And then what is population? This 25,000 will not be population?
Yes, sir.
Yes, it is population. Someone has correctly given the answer. Population, Pallavi, right. So now since you said this, I will also tell you that these are also two words which are used, supply and universe. These are also two words used, but at least I have seen that this word is not used by a well-known author, Henry Garrett. It is not used by Best and Khan. It is not used by Creswell. It is not used by Gay and Eration. It is not used by Donald Airey, and it is not used by Mowley. This many authors I can say that they have never said. But there is only one book perhaps, that is in Kurukshetra University by I.P. Agarwal. He has written some words from somewhere. So words universe and supply are also used. But in research, we have only sample and population. If someone uses, you can say you can use it, but they are not so popular, universe and supply. So here this 25,000 will be our population. And normally we write by n, word n. Normally, not a symbol, but like in physics and chemistry, we say that symbols have their usual meaning. When we say PV is equal to constant, P is only a that one is not. So it's n also, you cannot challenge. But normally population, for population we write n, capital N. Then from this, now you have drawn a sample of, say, you want to say 20%, and you have selected 5,000 from this 25,000 by any method of drawing a sample. Then this 5,000 will be, this 5,000 will be your sample. Is it correct? Or no?
Yes, sir.
Somebody was asking experimental group. I will come little later. So 25,000 is your population. And from this, by chance you said that I will be going to draw 5,000 from this. So this 5,000 will be your sample. And that we write with capital N. Or small n, sorry, small n. Right. Now, there are people, they are using two words, target population and experimentally accessible population. Target population and experimentally accessible population. For this also, I do not agree. Why this target population and experimentally accessible populations? Somebody said that I would like to study problems of first year students in the university and colleges in Tamil Nadu. And then I will study only students' problem at ANNAMALAI. And first I will define first one, all students of Tamil Nadu studying in first year in 2021 as a target population. And my experimentally accessible population will be students of Tamil Nadu University, ANNAMALAI University only. In a way, he is true. In a way, he is true. But I do not agree with this. Because your generalization will be not to the target population. From target to experimentally accessible population, which could be 25,000 in first year in ANNAMALAI University. From that, you are drawing 5,000 sample. You are applying some statistics, inferential statistics, and you are generalizing. You are inferring. So that inference, that jump will be only with sample to experimentally accessible population. But there is no statistics from experimental accessible population to target population. That is not there. So if someone is using this word, be careful. And this clarification you should give. Right? Now, how will you define population? After definition, you have given definition, but what are the limits of population? How population is, see, I have seen many theses where population is not defined, not explained properly. Even I say that size of population also should be written. There are people, they don't write. I think if you read a book by Cochrane, Cochan, I don't know whether I'm correct or not, but Cochrane, you just put in Google and you will get a book also, Cochrane. He has said somewhere that size of population also should be mentioned in your thesis, dissertation, or whatever it may be. Otherwise, how can you say, if you say 10%, then you don't know the size, then how can you go for 10%? 20%, how do you go? So that is also there. Cochrane somehow a bit difficult. If you had a mathematics knowledge, then I think you can do it well. But there was another book also in local language I read, and he also clearly supported that population size should be clearly specified. Now, population can be defined in terms of what? Number one, geographical limits. If you are writing, write down the point. Geographical limits. I won't say everything and everybody to write, but here you make a point. Geographical limits. A population study could be confined to a village, a town, a district, a province, or a country, or whole world. But at least one who is doing research, she will not go to all whole world and even country and even state. That will be a bit difficult for him. But there are studies conducted by UNESCO, WHO, World Health Organization. They conduct the study for entire world. Census survey, that's what they call census survey. Entire census has been taken into consideration, and such studies are also available. So whenever you write your population, geographical limit will be there. Like that I said, that to study the problems of first year students of ANNAMALAI University in Tamil Nadu. So it is only one university which is situated in Tamil Nadu, right? If there are more than two ANNAMALAI University, then also you can find out that which state, which city you are studying. So number one is geographical limits. You should clearly mention, right? Second, some studies are restricted to age and grade. Some studies are restricted to age and grade. What is that, age and grade?
Demographic.
Some studies are restricted to age and grade. Have you seen any study with such studies?
Age limitations of the population.
Person's behavior.
Demographic. Demography.
Demography. Have you studied any intelligence test? Have you seen intelligence test? Somebody is referring to, Lata is referring to senior citizen. Okay, I got one example.
Memory and...
Before I retired, there was someone, a faculty of food and nutrition people from faculty of family and community study, community science, family and community science. They came and they wanted to study the BP level, diabetes level of these professors who are having age of 55 or more. So here in this study, what is the focus? Age. Only those age group studies from, I think we have a retirement age of 62. So from 55 they have started and 62. Whether do they have more BP, diabetes, right? So this is related to age. There are intelligent tests which are meant for a particular age group only. This intelligence age group can be given to, yeah, that's mental age, but that's a different, because what is intelligence? CA upon MA multiply by 100, you will get that intelligence. But some test is given to only those who are 10 years old. Some test is given to only 15 years old. So age also comes in some population. Not all this. Any one of these, I will be talking to you about 4 or 5 characteristics. Amongst them, wherever researcher is interested, that is very much important. So age and grade. Sometimes we say this test can be given to 5th grade students. This test can be given to 9th standard students, 9th grade students. I had prepared one test which is known as mathematical weakness test. Mathematical weakness test. That test can be given to those students who are entering to class 8 and completed 7 years of schooling successfully. For them only this test was there. At entry you can give it. So here grade is very much important. And you know that in India grade and age, they are related, because if you enter at the 6 plus 1, 6 plus 2, when you are in 12, you are 18 years. When you are in 7th, you are 13 years. So that relationship is also there. So anyway, so second is age, third is grade. In defining population, we use geographical limits, age, grade, gender. People start checking testing the hypothesis on gender, whether there is a difference between male and female. Of course, now sociologists, they don't like this. On one side you talk of the equality, and other side you are comparing this. So not it is being appreciated. But if you don't take any hypothesis, referee will say that you have not tested the hypothesis. So by the fear of external referee or examiner, we go for such things. So gender. Is there any difference in the gender? Mathematics achievement, English achievement, role perception, attitude of the people, then we check whether there is a significant difference between boys and girls, male and female. So that is geographical limits, age, grade, gender, then SES, socio-economic status. Some studies are considered keeping this in mind. SES, socio-economic status. But measurement is quite difficult. How will you measure? You require a latest updated test. Otherwise, if you use a test which was prepared by Kuppuswamy before 20 years, will not serve the purpose. There was a test prepared by Vora before 20 years, which will not serve the purpose. So latest test. Anyway, that is not the concern here. But SES is also studied with respect. Even somebody was talking about the experimental design. So we classify students in terms of high SES, average SES, and low SES. And we see whether your intervention was successful in high SES, average SES, or low SES. So such studies are also there. Then physical attributes, we don't go for that. I think in education, we don't study the difference of achievement between students whose weight is 50 and 55. No, that is not there. Or we don't check their intelligence. So height, weight, blood group, all these things, I think we leave it for the medical people, that what is the relationship between weight and diabetes, weight and BP, weight and some other things, right? Like height and all other things. So these physical attributes, we don't go. But still there are some slogans you can say for cat eye. You know cat eye people. Whom will you say cat eye?
Brown eyeballs.
Yeah, for them, I don't know. Have you heard anything? Some people say they are cunning people. Cat eye people are cunning people. Huh? Don't take it personally, but I have heard this. So such conclusions are not valid here. But anyway, so those who are in the medical science, those who are in pharmaceutical science, they might be using these also, physical attributes. So, and last is psychosocial behavior. Last is psychosocial behavior. Police people are doing this. They study only delinquent people, neurotic offenders. Somebody is studying only those who are hospitalized continuously, frequently. Some people, they study schizophrenic, unsuccessful, successful people in a particular examination. So that is also there. But I think psychology people, sociology people, they go for more of this. So population can be defined as any one of this or more than one of this. That is another definition. Population can be defined as, it may be from geographical limits, it may be from age, it may be from grade, it may be from gender, it may be from socio-economic status, physical attributes, and psychosocial behavior. So you can take any one of this, that will become your population, right? It depends upon you, what you want, your interest. Another word sometimes we use, known population, a population for which estimates are known. That is known population. And for that, you have to estimate they are known population. But these are also not that popular words. These are also not that popular words. Because who will study the population? If population of 10,000 is there and you want to study their achievement, you enter 10,000 scores in the computer and you will get immediately. So it will become a known population. But without that also, if you study 5,000, then also your result will be reliable and valid. So instead of studying 25,000 students, you study 5,000 students, and your result will be reliable. Your result will be, conclusion will be valid. So from this, can you say, what are the advantages of sampling? Instead of studying entire population, capital N, we go for a small sample, N, small n. But our results are far,
Easy
far
computation.
easy computation. You can say and 2 rupees per paper, it will be 20,000 rupees. It will be 20,000 rupees. Sorry, not 20,000, because 25,000 people, 4 pages. So 1 lakh into 2 rupees, it will cost 2 lakhs rupees. But instead of that, if you go for 5,000, a sample of 5,000, then a cost also will be reduced, right? Somebody has given economical answer. So a reduced cost will be there. And when this type of even wide travel is there, then also it will reduce, because all are not available with Chennai. Some of them are in a different parts of the Chennai and you have to go. So field work cost also will be reduced. Your speed will be greater. Here in this case, speed will be greater. Data can be collected, tabulated, and summarized more quickly. And there is always a greater scope. Survey using sampling techniques provide greater flexibility of the scope and greater accuracy. So these 4 points you have to keep in mind. Advantages of sampling: reduce cost, second is greater speed, greater scope, and greater accuracy. In PhD, we wait for 6 years, but there are some industries, when they want to take up the study, they want result within 3-4 months only. MBA evening. After this, I had a class in MBA only today, and similar topic I have to discuss. So advantages of sampling, that even when interview is there, time is also a problem. When you want to conduct the interview with 25,000 and interview with 5,000 and interview with 500, so that will be a bit difficult. So these are the advantages. Nobody will ask you nowadays in the NET slate also, or in PhD entrance also, this will not be asked, but you should know. Now, next question is, what is a representative sample? What is a representative sample?
Proportional to the population.
That is in terms of the size. Number one, proportional to this. Okay, I want to study, say I had 25,000 students and I want to study their problems. Now I should know my population and my variables. I would like to study, these are the students of Annamalai University, 25,000 students. So characteristics wise, there is a gender. There are boys and there are girls. Fine. Second, there are students coming from urban area and there are students coming from rural area. Fine. There are students who might have taken their secondary education up to 12th in Tamil medium, Malayalam medium, or they are studying in English medium. So these many variables I have kept in mind to study my problems. Medium of instruction, area of residence, and gender. So when I select 5,000 students from these 25,000 students, this characteristic should be proportionately presented. Somebody has used the correct word. Equally presented in 5,000 also. This 5,000 must contain students from urban, students from rural, students from Tamil medium, students from other medium, students, girl students and boy students. If they are there, these are the characteristics where I am interested. You can go beyond also. You said, I would like to go for some other characteristics also. Those who are weak in their achievement and those who are good in achievement. But then your 25,000 students and 5,000 students should have all these characteristics, variables which we want to study. Then you can say it is representativeness. But here, one word you have to put, that a good sample will reproduce all characteristics of the population with greatest possible accuracy where researcher is interested. Because I said that I am not interested in a backward student and an achievement and higher student. No, that is not. My interest is gender. Somebody say, okay, my interest is SES also, social. So wherever you are interested. So the very good definition of a representative sample reproduces all characteristics of the population with greater accuracy and in bracket where researcher is interested. Right? Right? Second characteristics of a good sample is free from error due to bias. What is that? Free from error due to bias.
Researchers should not show favoritism in selecting the sample.
Preference and prejudice should not come. Preference and prejudice should not come. Okay, I will select this 200 students because they are very good students. They know me well. They are from my area. They come with me in the same transportation and all other things. So such biases should not come. So free from error due to bias. Third thing, free from random sampling errors. What is that? Free from somebody has written a question, but it disappeared. Just one again, you can put it. I will be thankful. So it should be free from random sampling errors. What is that? Let me first say error. What is error? Sometimes on a frequent measurement, your answer is not exactly the same. I give a very simple example that with a foot rule scale, you start measuring the length of a room. You have measured, all the time your answer was correct. Consistent, you can say. But when later you find that that foot rule was not exactly 12 inch, it was only 11.5 inch. So there is an error. So this is constant error. But instead of you measure with the help of a footsteps, and you measure 25 times, and all 25 times your answer is different. So this is also an error. Error in instrument, error in measurement. So those who know well measurement, I think who is the best author who has written about the Guilford has also written a good book on measurement. Then there is another.
Nunnally, sir.
Huh?
Nunnally.
Yeah, he has also done a good job. And when there was somebody from L name I know, he had also done this. So
Levens.
what happened to video?
Levens scale of measurement. Levens.
Once. So what happened? Is it time over or what? For Zoom?
No, sir.
My video is now something stuck up.
You are visible and audible, sir.
Huh?
You are audible and visible also.
But here the video is stopped. You can listen to me.
Exactly. Yes, sir.
But why video is stopped here?
We can also see you, sir. We are seeing you.
But it is it's like a photo. Only one photo shows on the my mobile screen.
Maybe it just froze for you, but it will come back.
1 minute. I will leave for a minute and then I will start again.
எனக்கு இத கொஞ்சம் எடுத்து கொடு. அத அவுத்து கொடு.
Hello. Yes, yes. Sir has left the meeting. He will join soon. Let us wait for him. So there will be no audio and video. Sir will join soon. Please wait. Yes, sir.
Now you can hear?
Yes, sir. Yes, sir.
Okay. So we were discussing on the what is a good sample. So in good sample, first we say it's a representative sample. And in representative sample, we started with what is representative. Then we said that a good sample will produce, rather reproduce all the characteristics where researcher is interested with a greatest possible accuracy. With a greatest possible accuracy. That is a representative sample. Second, we said that it should be free from bias. It should be free from error due to bias. So preference and prejudice should not be there in selecting the sample. Okay. Third is free from random sampling errors. We will discuss this detail little later, but error I explained that could be a constant error, error of measurement. Right? Then next is no substitution of originally selected units. No substitution of originally selected units. What is that? Out of 25,000, you have selected 5,000. But later on you say that this 100 according to me are not appropriate for me and I will change them. So once they are selected, once they had become the member of your sample, you can't change them, right? So this should be keep in mind while selecting the sample. So what is a representative sample? I have answered. It produces all characteristics with greater accuracy where researcher is interested. Where researcher is interested. Second, it should be free from the biases, error due to bias. It should be not be there. And it should be free from sampling errors also. And originally substituted units should not be replaced. So these are the points to be keep in mind for a representative sample. Then there is another word which is there. What is an adequate sample? What is an adequate sample? So a good sample had two characteristics. A good sample has two characteristics. One is it is a representative sample, and second, it is adequate sample. Now, what is adequate? We are not discussing right now, but before that, we will go for another word which is known as a bias sample. What is a bias sample? A sample is also a bias sample.
Where equal chance is not given for sample.
That if it is not representative, it is bias. Other way around. If it is a sample which is not representative, will be a bias sample. So you can say sample drawn with prejudice, preferences in the researcher's mind, or some units are favored unduly, then it becomes a bias sample. So bias sample may be because of imperfect instrument. While selecting, you may have an imperfect instrument, your personal qualities of the observer, defective techniques, and experience has shown that human being is very poor instrument. So his biases also will always come. So that is a bias sample. So bias comes in the sample because of use of non-random techniques, use of non-random techniques, use of unscientific and careless randomization, use of unscientific and careless randomization. And third, errors of measurement, errors of measurement. And fourth is non-response and experimental mortality. What is that non-response and experimental mortality? Non-response. You have selected a sample of 5,000 out of 25,000.
The subject we have selected, if they don't answer.
Yes, say when you have collected the data and when the bunch was with you, you have found that 1,000 had not responded out of 5,000. 1,000 has not responded. And you never know these 1,000 are from which category. Whether they are boys only or they are urban boys only, all these things will be there. So, loss of respondent, you can say. Sometimes you start with experimental design. There are 40 students in one group. An experiment continues for, you can say, 6 to 7 months. And in between, some parents have transferred, some have changed the schools. As a result, student will go. So within 40 sample also, if 6-7 people will go, that will have a great damage on your experiment, because you never know that these 7 people represents what. They may be with a little high achievement level student, or they may be with a low achievement student. So they can pull down your mean also. So these are the biases in sampling, right? So use of non-random techniques, unscientific and careless randomization, that we will discuss, errors of measurement and drawn response. So these are the things. Now again, 2 words. Again, I am giving you 2 words. One is statistic. You said correctly. There is no S here. You have to take care. Statistics. Garrett has written S also, but that is when more than 2 such measures are there, then plural sense it is written. Otherwise, statistics is a subject. It's a science of estimates and probabilities. That is the definition of statistic. But here, statistics means it is a measures computed from the sample. Statistic is a measure calculated from sample. Now, what is that? Measure calculated from sample means what? suppose you want to study the scientific attitude of students in a particular region. Scientific attitude. You have prepared a scale for measuring the scientific attitude, and scoring and everything is there. Now, if you find out your sample was say 10,000, or a population was 10,000, and from that you have selected sample of 2,000. You give your scale, scientific attitude scale, to this 2,000, and then you find out either mean, median, mode, or whatever it may be, measures of central tendency or measures of dispersion. That particular thing is known as statistic. If you say that 55 is the average or mean scientific attitude score of these 2,000 students, that is sample. Population was 10,000, 2,000 was sample. You have distributed this your scale to 2,000 students, and luckily you get all 2,000. Then you find out the mean of scientific attitude score, and that mean was 55 point something. So this is known as statistic. N. So S and S, remember, sample and statistic, and parameter and population and parameter. Population parameter is always unknown, and the entire process of research is such that you have to infer. A scientific, what is scientific research? That is this only. Somebody is asking for formula. I am coming to that also. Where we were? Population and parameters. So entire process is you have a well-defined population. Remember the word well-defined, because I always say size and those geographical limits, age, norms, grades, or psychosocial characteristics that should be there. Then only it will be well-defined, and along with the size. So from 10,000, you have selected 2,000, and you have measured, and what has come is 55. Now for this 55, you will apply some statistics. That I think next lecture is that only. And you will have a confidential limits. And with these limits, you can say that the population mean will be within 52 to 57. That will give you the idea. And from that you say that that will be your parameters. So estimating parameter for 10,000. So that is parameters. So parameters are thought of a fixed reference value. So I hope it is clear, right? Now somebody was asking, what was that formula for selecting sample? Somebody was referring to this formula. Adequate sample. If you refer, you will get that formula also. Which book I won't be able to say, but there is a book by P-A-R-T-E-N, Milred. You write down the name. P-A-R-T-E-N M-I-L-D-R-E-D. It was written in 1950. It is New York Harper. And they have given a formula. And similar formula has been written by another book at Gujarat University, Professor Satish Prasad Shukla. He has also given that formula. It is N is equal to sigma Z upon T whole square. I will not be able to write, but that formula is there. And if you refer Y.P. Agarwal, he has also quoted this. Otherwise, Cochrane. He has given this formula that from you, if you know population size, if you know acceptable error, if you know the preliminary estimates of the population and Z value, then you will be able to get it, right? Now I am talking on that only. So suppose now, answer to the adequate sample. Whom do you say that it is adequate sample? So for that, very much important thing is you should try to know what is standard error of mean. So I will go to sampling error now. So formula wise, madam, that book is there, or you can refer the book by Professor Satish Prasad Shukla from Gujarat University, or Cochrane, or that another book I said, I forgot the name. So that you can refer and you will get idea, right? Now, what is a sampling error? Because earlier also I said that it should be free from the sampling error. Listen now. You have 10,000 students as a population. 10,000 students studying in class 10th, and you are studying its achievement in English. You can write achievement in English of 10,000 students studying English. So what is your population? 10,000 students of Chennai city studying in class 9th in English medium. This will become, you have specified everything. So well-defined population is there, but 10,000 students are there. Now, I will say that 10 of you select different samples from the same population. Different samples from the same population. Remember the word. I hope you are getting. Yes, good. Somebody has written Satish Shukla. It is not nearby, otherwise I can show the publisher also. But anyway, so again, you have a population of 10,000. You don't want to draw one sample. You said, I would like to draw 10 samples. So X, Y, Z is drawing sample. So we have now 10 samples. You observe now these 10 samples. I don't know, I had example, or I will ask them, you to write also. That example is different. Okay. So now you have 10 samples from the same population. You want to study the achievement in English of students in Chennai city studying in class 9, right? And English medium. And you want to study their English achievement. 10,000 is population. Geographical limit wise, you have said that it is Chennai city only. They are class 9th only. And they are studying in English medium. So all characteristics there. And from that, now you want to draw randomly 10 samples. I will draw one sample, you will draw one sample, like that everybody will draw the sample. And you will see, yes, somebody speaking something. These 10 means are never identical. Remember now, listen to this word. This 10 means, no two samples have identical means. No two samples have identical means. So this is known as a sampling error. Remember, this is known as the sampling error. If n, here we have restricted to 10 only, but if you say, if n number of samples are drawn from the same population, and whatever the characteristics you measure, these 10 means are never identical, and that is known as a sampling error. Let me take another example. Quickly, if you have pen and pencil, just write down. I will take one example that a test was administered. To 10,000 high school senior students. Write down n is equal to 10,000, you write. Because we have only 14 minutes now, and this will be a bit statistical problem. They had been given one test. College entrance examination board test was given to that. So forget it, but you say that 10,000 student is population, right? That population is from, you can say 9th standard, okay, from Chennai, okay, fine. So geographical limits and everything has come. You have given them some tests, a test of mathematics. And you have computed their mean and SD of this. So mean has come to, write down, you have to write, mean has come to 500. and standard deviation is come to 100. For this 10,000, remember. So what is this known as? Is it statistics or is it parameter?
Parameter.
Very good. So you have a 10,000 population, and by chance you have a calculator and computer and everything. So you have calculated the mean and standard deviation, which has come to 500 and 100. Now, you will draw by some randomization or something, you will draw 10 samples having size 25. Write down. You will draw 10 samples from this 10,000, each of 25 size only. So you will have 10 means. Now I will ask you to write down 10 means. I had a data. So write down 1, 2, 3. On one column you write down 1 to 10. Doing? Dr. Raja, you are writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, so these are the 10 samples. Now you write down mean of 10 samples. Mean of first sample is 528. I won't repeat now. Mean of first sample is 528. Second, 486. Third, 483. Fourth, 523. 487. 476. 513. 516. 472. And 506. These are the 10 means. You have drawn 10 samples. Size of each sample is 25. And this is the mean. Somebody has written, check, 528, 486, 483, 523, 487, 476, 513, 516, 472, 506. So could you find no two means are identical? Is this statement true now? No two means are identical. What is the highest? I think minimum is 472 and maximum is 528. So range is also very high. But what I want to conclude, no two means are identical. And that is a sampling error. And if you find 528 minus 472, that is the range of error. So no two means are identical. That is known as the sampling error. Now, what is the mean of this? Could you find out? Or it will take time. Mean of 10 means. Write down. The total of all this 528, 486 is 4990. I will not. 4990. You can say sigma x bar because this is a mean of means. So that is 4990. You are getting my point? Why what I am doing? Yes.
Yes, sir.
Yes. So I have drawn 10 samples, each of size 25. And I know the population mean 500. And I have now 10 means. And 10 means total is coming to 4990 divided by 10. What is the mean?
499.
499. And what was original mean? 500. So this difference is known as standard error of mean. The difference between parameter and statistic is known as standard error of mean. But we have used inductive measure and we have seen that this 499 divided by 10. So you have selected 10,000 population. From that you have only gone for 250 and you are getting 499. So a representative sample of 250 also will serve your purpose. That's what I want to say. 250, 25 each and 10 samples. So which is very close to the population mean, that is parameter, right? Now, if you find you have written all these 10 scores, X. So now you take X minus X bar, standard deviation. You write in your note X minus X bar. What is X bar here? 499. And if you find out the standard deviation of this distribution, that is known as inductively standard error of mean, SEM. If this is clear, fine. Is it clear or any doubt? Since you have shown little more interest, I probe. Otherwise, I never go to this example.
Clear, sir.
Group is
Perfect.
quite enlightened.
Yes, sir.
So we have a 10 means. 10 means of mean is also 499. And we have gone for standard deviation. So first one you can say 528 minus 499 plus 29 and last 506 minus 499 plus 7 and then you square it, x minus x bar whole square. X minus x bar whole square because the standard deviation formula is sigma x minus x bar whole square divided by n, and n is 10 here. So that comes to 1944. You write down standard deviation of means of standard deviation. I think your next speaker has already come, Paraksha. So that is 919.44. That is known as standard error of mean. So I hope I have clarified these 2 points. Number one, sampling error. If n number of samples are drawn from the same population, then we will get n means. Here 10 means. So these n means are never identical. There is a difference, and that difference I have shown you, and that is known as the sampling error. And sampling errors distribution is normally distributed. Remember, यहाँ 10 hai, so it is a bit difficult to say normal. But if it is 100 means, you can plot them, Ojai or not Ojai. You can add frequency polygon, and you will get a normal curve. So these errors are randomly distributed, normally distributed. And that distribution standard deviation is known as standard error of mean. I hope it is clear, right? Now, what is the formula for that? Deductively, this is we have done inductively. Deductively, if you want, then you write down sigma x bar. Sigma, you know how to write sigma. I don't know. I will not be able to show you on this. Sigma, how do we write? This type of thing, sigma, x bar. Getting sigma. There are two sigma. Summation sigma is different. This is different. So sigma x bar is equal to, formula you have to write, sigma upon square root n. You can write small n, and that will be better. I hope you have written sigma x bar is equal to sigma upon n. I don't know. You will be able to know. ये थोड़ा उल्टा दिखाई देगा. Got it? But you got it? Yes or no?
Yes, sir. सीधा ही दिखाया.
Yes, sir.
Okay. So now you have example where I said sigma is 500. Sorry, sigma is 100. And n is 25. So what is standard error of mean? करिए थोड़ा कर, please do it. Sigma is 100 divided by square root 25.
20.
20. And what was you have calculated from that standard error of mean?
19.44.
Very good. So could you realize what is the difference? Error kitna? What is the error? Mean was 500 and we calculated from 250. That was only 499. Standard error of mean where you have calculated from the formula, then it is coming to 20. But when you have gone from that, it is 19.44. So that is the logic of the sampling. That if you go with sample, error will be there, but not a big error will be there. That is the standard error of mean. Now, only one point. Still 4 minutes are there. Have you studied the variations? Sigma x bar is equal to sigma upon n, square root n. Now, if I keep n as a constant or 1 upon n as a constant, then I can always write that sigma x bar varies as sigma. You write sigma x bar varies, you know, varies, what is the varies? We write like this, like infinity. Varies. So sigma x bar means standard error of mean is directly proportional to standard deviation of population. समझना की try करिए. Standard error of mean is directly proportional to the standard deviation of the population. Your population is quite heterogeneous, then standard deviation will be more. So standard error will be automatically more. Remember, heterogeneous. There are some cities which are quite heterogeneous. About Chennai, I don't know. But if you go to Surat, if you go to Baroda, these are heterogeneous, cosmopolitan cities where you will find people from Kerala, people from Tamil Nadu, people from West Bengal, people from MP, UP. So group will be quite heterogeneous. So in a heterogeneous group, standard deviation will be more. And if standard deviation is more, your standard error will be more. So to reduce standard error, what to do? If you put now sigma as a constant, then standard error of mean is inversely proportional to size of the sample. Size of the sample. Suppose here we have taken size 25. Instead of that, you change your size 100. What will be the standard error of mean? Someone can calculate 100 upon square root 100. So 100 upon 10.
10.
So instead of size 25, you have increased it to 100. Your standard error of mean, which was earlier 20, has gone to 10. So if you can understand this point very well, fine. That's what I want to conclude. If any query, questions, please ask 1 minute, then we will conclude. We will continue tomorrow, no problem. Okay, then we conclude. If there are no questions, queries, see you tomorrow again at the same time.
Okay, sir.
Thank you.
Thank you so much, sir. Sir, today's the session started with probing questions to elucidate the answer about sampling by providing suitable example. It was very highly informative, highly interactive session, sir. We learned about population and the sample in detail. We also learned about limits of population like geographical limit, age limit, grade limit, etc. Representative samples, biased samples, errors of measurements, non-representative samplings, etc. We learned a lot in today's session, sir, which we were not aware before. Thank you so much, sir. Remaining things we can learn tomorrow. We are eagerly waiting for tomorrow's session, sir. Thank you, sir.
Okay, thank you.
Good evening, sir. Paraksha, sir. Good evening.
Yes, good evening.
Shall we start the session, sir?
Yeah. Okay.
Okay, sir.
Sure. Thank you.
Good evening, sir. No need to introduce our today's resource person, Dr. Paraksha, sir. He has become very familiar with us, with our participants, but however, some of his traits should be highlighted. Sir is an excellent teacher, strong in his subject, in-depth knowledge, meticulous planning in delivering the subject matter, good in giving examples. Sir's passion for teaching is obvious that every teacher must imbibe these qualities to become an inspiring teacher. With these words, I invite you, sir, for today's session. Please handle the session, sir. Thank you.
Thank you, ma'am. Thank you. So we are again with the hypothesis testing. This is the third session that we'll be having an interaction. And I hope that you don't need a break in between. And as it is an offline, it is not an offline, it is an online. You can have a cup of tea or even a glass of water with you. You can keep it with you and you can sip it. You have that liberty because your videos are not on, right? Okay.
Happy learning, sir. Happy learning.
Okay, that's great. Actually, it happens after 1.5 hours of a session. There is a need of some refreshments, and I'm sure the participants now, after a week or so, they are now used to that. That it becomes very convenient and comfortable to them. So it's okay to have a cup of tea or a glass of water with you, to keep it with you. It's fine, not an issue, unless and until you focus over here. So what we did in the last session was we talked about which test to use when, to decide about your level of measurement. Then after knowing your level of measurement, if it is a scale level of measurement, then we have to check the normality. Now you are very much aware how the normality is checked, whether you want to do it graphically or you want to do it with a particular test. We have an option. We have done that in SPSS. So once that is clear that your data is normal, then what is the purpose of your project, of your research paper, or what is the objective? If it is regarding the average, then accordingly there are different t-test and ANOVA that you have to use it. If it is regarding standard deviation, it can be chi-square test or an F test, or we can go with another Bartlett test and so on. If your data is not scale, that is categorical, then you can go for a proportion test. So this is what we had discussed. And of that, 2 t-tests we have already done. Test for single mean and test for 2 means. So that much we had done it. Today, the incomplete part that was to be taken care of was for the dependent sample or the paired t-test, which I think 2 or 3 participants asked in the question answer session after my session on Saturday. So we'll be going that in detail. So when you have 2 samples, okay, let me share the screen so that it becomes easy for me to write. So you might have taken 1 sample, depending on your problem, you might have taken 2 samples. But if I take for 2 samples, then you have to understand that how the samples are selected. How the samples are selected, that also matters in our testing of hypothesis or to select the test. Okay, let me take this one. So samples, if I take 2 samples, I can classify that as an independent sample or dependent sample. When I say independent samples, that means the 2 samples are quite different. They are not related to each other. They are not dependent on each other. Like I want to check where there is more death due to COVID. In which state there is more deaths due to COVID? Is it more in Kerala or it is more in Tamil Nadu? I want to check this. So this means the individuals staying in Kerala and individuals staying in Tamil Nadu are quite different, right? They are not dependent on each other. Then thus kind of, if I want to compare with these 2 means, then I can go with the independent sample. But if I'm taking dependent sample, that means in a way we are taking sample only once, but it is a situation of before and after kind of thing. Before and after. One of the examples that I think Suhasini madam was asking about, it was the training program, that is IQ. Okay, there was a training program for IQ, and what was done before training, what was the IQ, and after training, what was the IQ. See, if I want to compare, or if you want to check whether the training program is successful or not, then this is what I can do is I will take 25 or 25 participants. I will find out what is their IQ before the training program. Once the training program is done, I'll check again their IQ. So you can see the objects, or the subjects rather, we can say, they are the same. Subjects are the same, but we are measuring it before a certain event and after a certain event. Then that is called a dependent sample. I'll take one more to clarify this. Suppose I take a company, say soap company Lux. Okay, a soap company Lux. Now they have introduced a new marketing or advertisement strategy. They have hired a new advertising agency. Now they want to check whether that advertising agency is successful or not. They want to check that. Then how they can do it? Whether their advertising agency is successful or not. Then what they can do is, one way to check out this is they will randomly pick out 50 stores, okay, 50 outlets where Lux is sold. Before campaign, before the advertisement, what was the sales? With the same 50 shops, same 50 outlets, what is the sale after the campaign? So now if I say the shops are same, outlets are same 50, but we are recording it before and after, then we can say, if we find that there is a significant difference between before sales and after sales, then we can say, yes, the advertising agency is successful, the sales has increased. So that kind of situation where your sample in which the subjects are same, but the data is collected before a particular event and after a particular event, then we go for a dependent sample, which is called a paired t-test. So for independent, we have already taken. We have taken care of that. Now we are taking for a dependent sample. So here the problem, I'm taking it over here. Okay. Yeah. Before that, the steps. Because I believe, again, the same thing. The steps will help you not to miss out any important aspect of your data analysis. So step one, now you are very clear, null hypothesis. Here, null hypothesis will always be equal to, so I will say there is no difference. IQ or sales before and after, there is no difference. Alternative, same 3 options, not equal to, greater than, or less than. Now, focus over here, assumption. Assumptions will check normality again, but will not check normality separately for before observations and after observation. This will not be checked. We will check the normality for difference between the two. So what we'll have to do it, we'll have to make a column of difference. You can take after minus before or before minus after, that is your choice. But we'll have to make a new variable which is difference. And we will check the normality for this difference. So understand, in independent samples, we were checking the normality for 2 separate samples because they were separate independent samples. So we had to do it separately. Here we'll check only for the difference. If difference is normally distributed, then fine, our assumption is valid. Okay. Again, one more part. No need to check whether the variances are equal or not, because actually the sample is or the subjects are same. So before and after, we will not check whether the variances are equal, what we were doing it in the independent sample. So understand the difference in the assumptions. Step 4 is same, T and the P value. Step 5 is also same, P less than or equal to alpha, we reject the null hypothesis, greater than means we'll accept the null hypothesis. So that is quite simple. Okay, now I'm taking an example. Okay, the example is the iron content of fruits before and after applying the farmyard manure. Okay, a special type of fertilizer kind of thing. So before applying that, what is the content of iron in it? And after applying, what is the iron content? So what has been done? They will find out from the fruits the iron content say they are taking one full yield of fruits. They are calculated or they have found out the iron content in all the fruits that they have grown, or probably the sample that they have selected from it. After that, they will apply the farmyard manure. Again, they will get a yield. They will observe the iron content. Now they want to check whether there is any significant difference in the mean iron content in the fruits before and after applying. So indirectly, they want to check whether farmyard manure is changing the iron content or not before and after. So this is, you can see the fruits are same, or the particularly we can say the yield from where we are getting the fruits are same. It is before and it is after. So this is a paired t-test that we have to go for. How the data will be entered? Before that, what will be our null hypothesis? First of all, as you know, it is d is equal to 0. D means difference is equal to 0. So what does it says? There is no significant difference. No significant difference between the mean iron content in the fruits before or after applying the farmyard manure. And here there is significant difference. So if you recollect the step that I was doing it, d equal to 0. So that was a red 0. So what we are saying, no difference. So this was step 1. Here in words, there is no difference. Take a negation of this. What will be negation of this? There is a difference. There is difference means d not equal to 0. Okay, so this is the alternative hypothesis. It is a two-tailed alternative hypothesis that we have framed. Now, I've entered the data. You can see in SPSS before value and after value it has been entered. Now, see the assumption. I have to check the assumption for normally distributed for difference. So before going further, I'll have to make a column of difference. So one way is to do it itself in Excel and then enter the data in SPSS. So some of you, those who are not comfortable with SPSS, will think we will do first in Excel the difference column and then we'll do it in SPSS. But I would suggest don't do that. Don't create your data and manipulate the data itself in the Excel file. Don't do that. Keep the Excel file as it is. Whatever extra columns, whatever manipulation you want to do it in SPSS file only. So what I'm doing it over here, I'm calculating a new variable called difference. So where I will get it in transform, in compute variable. If you click on compute variable, you'll get this particular menu pop up. So now target variable, that means our new variable, it is difference. Okay, it is difference. How we want to calculate D, it is your choice. After minus before or before minus after. Answer won't change because of that. So here I have taken after minus before. How this will be done? I'll take a live demo with SPSS itself. Those who have downloaded SPSS, the license version or maybe the trial version, they can practice all this. I will send all the data and all my files with all my data at least to Shailila madam, and you can ask her to get the data for your practice. Because actually Shailila madam had asked me to, so that the participants have an hands-on practice at a later stage. So she insisted that my participants should get the data so that they can practice. So that is good actually. Otherwise, what will happen? The workshop is done and it is done. You will not be able to recollect it unless and until you have a data, you can practice on it. Right. So what has to be done? Transform, compute. In compute, I'll make a column called difference. This is a difference, right? Here, after, so I'm clicking on after, then a minus sign, which will be taken from over here, minus before. Here. That's it. I'll be getting a new column now. So new column has been prepared. You can see now in our data file, a new column difference has been ready. and I want to check the normality of this difference. Now tell me, how normality will be checked? What are the steps for it? Anyone? You can write down in the chat box, or you can unmute and say. At least this much you know it. We have done that before. Analyze. Okay, Sumashini madam, analyze. In that, Shapiro Wilk test, good. QQ plot, that's fine, good. I think now you're able to recollect. Analyze, descriptive statistics. In that, what? Explore. Which variable I want to check? Difference. Take it in the dependent variable. Then plots. Here it is normality. So normality plots with test, I'll be getting it. I'm repeating it again. Analyze, descriptive, explore, select our variable difference, go into the plots, click on normality plots with test. It's okay. And we will get our output. So this is the output that you'll be getting it. This is the test for normality. This is the graph of normality, that is called a QQ plot. You can observe that in the this box plot also, but that would be difficult for you to interpret. Graphically, yeah, this is the QQ plot is the best way to check the normality. But here, this is the Shapiro-Wilk test outcome that we are getting it. This is all what we have done it, and this is the output. So what is our p-value? 0.536. For normality, what is the assumption we are making it? Data is normal. And opposite, data is not normal. I think now we have done it 2-3 sums for this, so it will be clear. So what is our p-value? 0.536, which is greater than 0.05. Greater means what? Greater means H0 is accepted. So data is normal. So my difference is normal. Perfect. Divya, perfect. Okay. So this means I am getting a green signal that your assumptions are valid. If my assumptions are not valid, then I cannot go further. Here, fortunately, my data is saying that difference is normally distributed. So I can go for a paired t-test. Now, how to go for a paired t-test now? Again, we'll go to the data here, right? We'll go to analyze. This is my data. We'll go to analyze, compare means. In compare means, here you can see there is a paired t-test. There was one sample t-test, independent, which we have discussed, and now paired t-test. So this is our paired t-test. My first variable, it is your choice. I'm taking it as a after, and my second variable, I'm taking it as before. You can interchange also, doesn't make much difference. I'm taking it after and before, right? Then, if you want, you can go with the options if you want to check what is this case, but nothing is required for it. Simply click OK, and you will get the output of paired t-test. You will get an output. So you will get the mean for after is 7.77, before is 7.670. That is a mean iron content. Standard deviation. Kothari sir was explaining about the standard error. We are directly getting the standard error in the output. Okay. And here also the same thing. For the difference, mean is 0.10. Standard deviation is 0.480. Standard error is also given to you. And we are getting the p-value also. So our p-value, here it is. So p-value is 0.529. Again, what was our null hypothesis? D equal to 0. What was our alternative hypothesis? D not equal to 0. So it was a two-tailed test. What is over here? It is also two-tailed, so direct comparison is possible. Now tell me if it was one tail over here, d greater than 0. Okay, if it is one tail, what to do with the p-value? Natarajan sir? Chitra? Yes, Suhasini ma'am. It is to be divided by 2. That's simple it is. So if the same question they ask, here the question was asked, is there significant difference in the ion content? So we have taken not equal to. If the question was, does the manure increases the ion content? Okay, if that was a question, we would have taken a one-tailed alternative hypothesis. Increases, so that was a question. Okay, so in that case, we have to take one tail. So in that case, the p-value will be taken as 0.529 divided by 2. Here, directly we will get it. It is 0.529. It is greater than 0.05. So null hypothesis is accepted. So that means d is equal to 0. That means there is no significant difference. With this, the paired t-test is done. Any questions for this before I go with the chi-square test? Any questions for this? Yes, Vinita ma'am. Perfect. There is no difference here. Great. So I assume now the t-test, yeah, it is clear. That's good. So I assume now the t-test, just to summarize what we had done it. Just because I want to show you the broader picture. It should not be the case that if once you know the t-test, then you forget about the other part. Yeah, what we have done it up till now, we have checked that our data is scale. We have done the normality part. Okay, we have done the normality part. We wanted to check the average. We have done that for one sample and for two samples. In two samples, we have done it for independent sample also and dependent sample. So this much we have done it. This is done. Okay, now what we'll do today is the chi-square test. You can do it chi-square test for standard deviation, but that is not done in SPSS. SPSS does not give you an option of going for chi-square test with this. But there are chi-square tests which can be used for one proportion and two proportion also. Again, SPSS directly does not give you one proportion or two proportion test also. But what we'll do is we'll take an advantage of one theory that I'm going to explain today, so that one sample proportion and two sample proportion can also be done using chi-square. But otherwise, as Suhasini ma'am was asking in the last session, chi-square is a non-parametric test also, and it is a parametric test also. What is the goal of this particular test? Depending on that, chi-square will serve you as a parametric, or it will serve you as a non-parametric. By the way, parametric means where we are dealing with a distribution. Okay, whether it is a normal. So here you can see they are normal. So it is, we are dealing with a distribution. So these are all parametric. When we say it is not normal, that means in that case we will be using the non-parametric test. Getting the idea? Yeah, skewed, we can say. Oh, perfect. So with this, I will go with the next part of it now. Okay, now we are going with the chi-square test. The screen is visible, right? Yeah, screen is visible.
Yes, sir. Yes, sir.
Okay. Okay.
Visible, sir.
Thank you. See the symbol, this is chi. This is the symbol of chi. This is chi square. Again, we are using not an English alphabet, because English alphabet otherwise will mix up with the words. So when all the statistical symbols are either Greek or some other language we are using it for, right? So this is chi square symbol, chi square text, or you can write down this as a chi. Many pronounce it as chi square also. It depends how you pronounce it, but it is actually ideally chi square text. Now, how chi-square comes into the picture? What is chi-square statistic? And why I'm explaining this? Because that will help you at a later stage when we deal with the proportion part. If I say X is a variable which follows, this is the symbol of follows. Okay, I say X follows normal distribution with mean mu and variance sigma square. This is the symbolic representation of how a long sentence can be written in statistical format. X follows normal distribution with mean mu and variance sigma square. So this is mean and this is variance. If I convert this into my standard normal variate Z, that means X minus mu upon sigma. So that means I'm standardizing my variables. X minus mu upon sigma. In that case, this will be again a normal distribution, but mean will be 0 and variance will be 1. Mean is 0 and variance is 1. Okay, so generally it happens that we always convert a normal distribution into standard normal distribution or variate. This is called a standard normal variate, Z. If I take a square of this Z, that means X minus mu upon sigma whole square. This is nothing else but chi square. So Z square is nothing else but chi square. Okay. And if I take this for one variable, this is chi square with 1 degrees of freedom. But if I take it Z is equal to xi minus mu upon sigma whole square, and then I take summation I running from 1 to n, then this follows a chi square with n minus 1 degrees of freedom. In short, if you don't want to go into this technicality, more technicality, one point you remember that chi square is nothing else but Z square. So Z square is nothing else but your chi square. Right? This is the theoretical part that we do. We derive all these things in statistics, but you are not expected to go for that. But this was required. And I'll take later stage why I am explaining this. Otherwise, straight away we could have done with that this is the data and we could do this. But why I'm explaining it, it comes to the later stage. Sure. Now, chi-square test can be used for multiple, probably I would say, for multiple purposes. One is for goodness of fit. Goodness of fit means I want to check whether normal distribution fits to my data, whether binomial distribution fits to my data, whether Poisson distribution fits to my data. That can be checked using chi-square data or chi-square test. And this is very important, very useful. Because what is happening, many times once you get a sample, okay, you have selected a sample. Maybe you have selected 50 observations, 1, 2, 3, 4, and so on. You have selected 50 observations. Now we want to check what is the distribution of this data, because you have taken a sample. And I want to check what is the distribution of this data. Then this chi-square test will help you to decide which distribution it is. So that is called goodness of fit. Okay, it can be uniform distribution, it can be normal distribution, it can be Poisson, it can be binomial. Depending on the data, we can check accordingly. Second and the most applied part is independence of attribute or categorical variable. That means I want to check the association between two categorical variables. Now, mind well, association or relationship between the two scale variable. If you have a scale variable, say height and weight, they both are scale. Height and weight both are scale. I want to check whether there is any relationship between them. How can I do this? I can do with correlation. So for scale, there is an option of finding out the relationship between the two variables which are scale, which is done by correlation. But if I take that my data is gender, okay, and I'm taking the second option like category of product bought, category of online buying. So here you can see this both are categorical variables. And I want to check whether there is any relationship between this or not. In that case, we'll go with the chi-square test. So chi-square test can be used for checking is there any association between, okay, between the two categorical variables. Okay, Abhilasha madam is saying it's non-parametric test used to know the goodness of it. Yes, it is an applied when the data is not normal. Yeah, because chi-square will not require any distribution to be followed. So I'll start with the first one. Okay, this is the table value for those who are doing it manually for them. First, we'll start with test for independence of two categorical variables. That means when you have two categorical variables and you want to check whether there is any relationship between them, we'll go for the chi-square. So your null hypothesis, again, will follow the same steps. Null hypothesis, two attributes are independent. Again, the same thing. What we were doing it over here, mu1 equal to mu2. Well, there is no relation, they are equal, right? So we'll say here that two attributes are independent, and alternative means two attributes are categorical variable are dependent. So first step is always they are independent, and the second step is they are dependent. Recollect now, what was the third step? Up till now in all the T tests that we have done it on and all, there was this assumption. Assumption of what? Normality. Here there is no assumption required. So we don't require the data is normally distributed. So that is why there is no assumptions required. So no need to go for a step 3. Directly we'll find out the test statistic, chi-square, and the p-value. And then step 4 is a conclusion. P less than or equal to alpha, we reject. Greater than alpha, we accept the null hypothesis. For those who have done it manually, might be recollecting it, the formula for chi-square is summation OI minus EI whole square upon EI, where EI is the expected frequency, row total into column total upon grand total. You might have done this before, but this is manually how it is done. Software will again, how can we reject the null hypothesis through SPSS? I think you can reject depending on the value that you are getting it. I hope that is the question, because that question is not clear still. How can we reject null hypothesis through SPSS? We can reject it if you get the p-value. If you get a p-value which is less than alpha, that is 0.05, we'll reject. That means there is no relationship between the two categorical variables. They are independent. I hope that was a question. I hope I have understood your question properly.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Perfect. Thank you. Achha, one more part. If it is a 2x2 contingency table, 2x2, that means what? Why 2x2? What means what? On one side it is gender, where we have done it as male and female, and other side we are saying online buying. We say regular and rare. This is called 2x2 table. 2x2 contingency table, where there are 2 rows and 2 columns. But if your data, it may be this way also. It may be gender, male, female, and third gender. And say online buying category. So it may be garments, it may be accessories, it may be perfumeries, it may be shoes, and so on. So here you can see that it is not 2x2. So if it is 2x2, and if the expected frequency is less than 5, then we have to go for continuity correction in the SPSS output. Because you might ask me in the output, if you look at it, the output that we'll be getting it in 2 cross 2, you will get the continuity correction. Then the question will be when to use it. So the simple logic is when you have a 2 cross 2, in this, there will be no requirement of continuity correction. In 2 cross 2, and if the expected frequency is less than 5, then we'll use the Yates correction. That is the continuity correction in SPSS output. I'll show you while we do the sum. But these are the steps in short. Say this is the problem. A public opinion poll surveyed a simple random sample of 1000 voters. Respondents were classified by gender, that is male, female. So this is again a categorical variable, gender. This is my one categorical variable. And voting preferences. So whether it is BJP, whether it is Congress or other party. You can just think it in that way. So I could not actually give the names. That is why I'm writing down as party A, B, and C. So what does the table gives you? That 200 males favored party A, 150 males favored party B, and so on, party C, and so on for the females. What we want to check, is voting preference affected by gender? Is voting preference affected by gender? That means, is gender and voting preferences related to each other? Can I find out a thing that, for observation from the data, that a particular gender favors a particular party or a particular gender opposes a particular party? That I want to check using the data. Now, this is not an easy one. So understand it very carefully how it will be done, how the data will be entered, and what you have to do it over here. Okay, what will be done? First step, while you enter the data in SPSS, the null hypothesis, we know it is independent. We take it as independent only. So the two categorical variables, gender and voting preferences, are independent. H1, that is, they are not independent, means they are dependent. So step 1 and 2 are clear. Step 1 and step 2, H0 and H1. Now, while you enter the data, this is very important, so understand this part. While you enter the data, you check it out in this way. So party A, B, and C. So here it is party A, B, and C. Males. Suppose I'm entering data for only males. So that is 200, 150, and 50. So here it is 200, 150, and 50. Then again party A, B, C. Now I will enter the data for females. So females 250, 350. Again, it is not compulsory to write down in this format only. You can write down the data, or you can enter the data as male ABC, female ABC. Then accordingly you have to enter the data, right? Also, you can enter the data in this way also. First of all, A, male female, B, male female, C, male female. So nothing wrong in it. It is your choice how you want to enter the data. That will not affect our final answer. That will not affect our procedure also. So nothing to worry about. Right. Now this data is entered. My data is ready into the SPSS. Now the important part, and now something that is strange over here, chi-square directly won't work over here if we use only this much data. Yeah, we can do it, Subhasin. Males ABC and females ABC. So what we'll do it now, in data, we'll go with the weight cases. Right? And in that, once you click on weight cases, this menu will pop up, and this count will be our frequency variable. We'll have to enter it over here. Why we are doing so? The reason is that we want to make SPSS understand that this is not a single observation. This one, A, male 200 is not a single observation. So while we give the weights according to count, what will SPSS do it? A party and male, they will write it down 200 times. So your observations will be A male, it will be written automatically 200 times. Then B males 150. So B males, it will automatically write down 150 rows for it. So while you are giving weightage, the data is now considered in SPSS that A and male are 200 times, B and males are 150 times, C and males are 50 times, A and F female are 250 times, and so on. That many number of rows SPSS will understand. So it will not take that, okay, A and male are only 200. That way, it will not be able to interpret. And so we are doing this extra work of data and giving weights to it. Getting it? Okay. Once you do this, your work is done. SPSS has now understood that party A and male is coming 200 times, party A and female is coming so many times, and so on. Once that is done, yeah, 1000 rows it will be total, depending on the number of individuals that you have taken a survey, right? So that is done. Now what will happen? Go into descriptive in that cross step. Because ultimately, what was our original data also? What was the format of our original data? Cross tabulation. This was one variable, this was another table. This is a cross tabulation. So now we'll go into the cross tabulation. Descriptive, cross tabulation. So this will open. Now, depending on what you want, you can select the party in rows and gender in columns. You can interchange also. Answer won't be affected by that also. Suppose I've taken party in rows, right, and gender in columns, because I want a two crossed. I want a two categorical variable. So one I have taken in rows and other I have taken in gender. Then what to do? The next step is go to statistics. Go to this part, statistic. And if you go to statistics, there will be a checkbox that is chi-square. That's it. Click on chi-square. Okay, we'll do it on the actual data now. So that you can get an exact feel about it, what is done. We'll enter the data. How was the data? It is your choice how you want to present it. So party A, male 200, female 250. So I'm saying I'll first find out the variable, that is party. Second is gender. And third is count. Now, I think Raju sir has explained all this, so I'm not going into that detail, but still, party is what? A categorical variable. So here it cannot be numeric, right? It cannot be numeric. What I have to take it out? A string variable. Gender is again a string variable. It means categorical variable, and count is this. So this is fine now. Okay. You can have this as scale variable over here. Okay, that is done. Now the data. So what I'm doing it, party A, this is male, this is female. So what are the numbers? 200, 250, right? Then party B, male, female. What are the numbers? 150, 300. That is ready. Party C, male, female. What are the numbers? 50, 50. Okay. This is done. This is done. So this is how the data is to be entered. If you don't want this decimal values in the variable, you can go with decimal and you can remove the decimal with 0. If you want, you can do that. Okay. This much is done. Then what to do? We'll have to give the weights, right? So what to do now in that case? Data. In data at the bottom, it is weight cases. That means you have to weight the cases according to the count. So weight cases by what? By a count. So this count is done. Okay. So if you do this, nothing will happen in the sheet. Your SPSS won't change. The data won't change. You can see the data remains as it is. But now SPSS has understood that A and male has to be written 200 times. A and female has to be written 250 times, and so on. It will do it. After that, what to do? Analyze. Then descriptive. Go into the cross steps. It is your choice. What do you want? Suppose party is to be taken in row, gender is to be taken in columns. Then go on statistic, click on chi-square. There is a checkbox, click on chi-square, it's continue, and then it's okay. Your output is ready. Now what you can do it, you have to double verify this, that the output that you are getting it over here, that is A, B, C and female, male, does it match with our original data or not? That means we need to check whether SPSS is understood at what we have entered the data, or there is some error that we have done in entering the data. So here you can check this. Party A 250, 200, yes, it was the same thing. B 300, 150, was it the same? So according to that, we will get it, the output. This is out. So this is the value of chi-square, and this is the value of P. So what is P now? P is 0.000, it is less than 0.05. Less means what? We reject the null hypothesis. That means gender and voting preferences are not independent. They depend. That means voting preference is affected by gender. Okay? And this kind of study are actually done in politics. In the last session, there was some of you were asking about, can we apply this in politics? It can be applied. And it may be that because of this outcome, Congress this time have done with Betiya Kam Nahi Hai. In UP, they have launched a campaign, Betiya Kam Nahi Hai, Betiya Abhi Ladegi. They have focused on gender-based. Same kind of analysis can be done according to the religion, and on that basis the political strategy is decided. So a lot can be done using this kind of here. Anyone is asking, or there is some other background noise? I assume there is a background noise. If you want to ask, you can write down in the chat box. Otherwise, my hypothesis, it is a background noise. Okay. So next part is to test the goodness of fit. So if the independent of attributes is done, or to find out association, is there any association between the two categorical variables? We have done it. This fine. Perfect. Hypothesis accepted. Okay. Now the second is goodness of fit. Steps are same. There is no assumption over here also. Only thing, there is no significant difference between observed and expected frequency. What is the previous assumption? There is no relations, or we can say that categorical variable are independent. But because that was the case for independent of attributes or independent of categorical variable. Here it is goodness of fit. We want to check whether our expectation and the actual value match with each other or not. So here there will be no significant difference, and there is significant difference between observed and expected. Then the third step is the p-value, chi-square and the p-value, because there is no assumption, and same way there is a conclusion. Right? Okay, we'll go with an example. I have taken a very simple example so that everyone can understand. I could have taken biostatistical example, or I could have taken engineering examples, but that would be difficult if the domain is different. So I have taken a very simple example which all domain experts can understand. The number of road accidents on a particular highway during a week is given below. Can it be concluded that the proportion of accidents are equal in all days? So what is done? What is done over here? Monday, there were 14 accidents. Tuesday, 16 accidents. Wednesday, 8 accidents, and so on. What we wanted, that number of accidents are same, whatever day it might be. So we are assuming it. We want to check whether it is Monday or Sunday, Tuesday or Saturday, the number of accidents are more or less same. That means indirectly, we say it is a uniform distribution. Uniform distribution means what? We say it is equal probability, like head and tail. Head and tail probability is equal, half and half. Or throwing a dice, 1, 2, 3, 4, 5, 6. Probability remains the same, 1 by 6, 1 by 6, 1 by 6, 1 by 6, and so on. This is called a uniform distribution. So here I want to check whether it is Monday or Sunday, the number of accidents are equal or not. That we want to check. So what we'll do it over here. First, I would advise you put it on a silent mode or switch off your audio.
இன்னைக்கு நானு பூண்டுலாம் எடுத்துட்டு போய் மேல காய வச்சுட்டு சாயந்தரம் வந்து எடுத்துக்கலாம்.
Thank you. So here we'll assume that the proportions are equal. That means it is uniform. Whether it is Monday or Sunday, the number of accidents are same. Alternative, it is not equal. Right? So we want to check it is a uniform distribution or it is not uniform distribution. Indirectly, that is why it is called goodness of fit. So we want to check whether it is Monday, Tuesday, Wednesday, Thursday, or Sunday, the number of accidents are same or not. Right? Now, what we'll do is we'll enter the data. This is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and the number of accidents. Now, this is how the data is to be entered. I can do it Monday, Tuesday also. What I've done it over here, 1, 2, 3, 4, 5, 6, 7. And the number of accidents I've written it over here, 14, 16, 18, sorry, 8, 12, 11, 9, and 14. This is how I have to enter the data. I have coded. What I've done it, I have coded over here. So these are the values. I think Raju sir has explained that. Here, once you write down over here, and if you click on this, I have entered in this way. 1 means Monday. So though I have entered 1, now SPSS will consider it as Monday, 2 will be considered as Tuesday, 3 will be considered as Wednesday, and so on. I'll just take 5 minutes if you want. I will explain this. Suppose this is the data. I'm writing down my first variable as day and the second variable as accidents. And I'm deleting this third one. We know day, it is considered to be numeric, but I will be by numeric, I'll explain it. Okay. And this is also numeric. And now I'll write down over here values. So what I'll do in values, when I click on values, 1, it means Monday. Then add. 2, it is Tuesday. I hope Raju sir has done this, so it will be clear to you. Then 3, it is Wednesday. It is always better when you code, you let the computer know also that this is what you have done it, so that output that you get will not be in the form of 1, 2, 3, 4. 5, it is Friday. 6, it is Saturday. 7, it is Sunday. Okay, now you see the data view. This way it will be. I'll write down 1, 2, 3, 4, 5, 6, 7. Number of accidents, 14, 16, 8, 12, 11, 9, and 14. Okay, you can check whether you have done it correctly or not. What to do? There is a sign over here, 1 and A. That means it is numeric and alphabet. So here, if you click on that, it will show you, okay, it is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And if you click on again this, it will show you what the code you have used it. 1, 2, 3, 4, 5, 6, 7. So I hope it is clear how the data is entered. Great. Perfect. Now what to do? I'll go back to my presentation. So this is what we have done it up till now. Now I'll go with again chi-square. So now we are going with a non-parametric, in that legacy, in that chi-square. Where I'm going it, non-parametric. Now up till now what we were doing it, descriptive statistics in that cross step, and then we were doing it the chi-square. In the cross step, we were clicking the chi-square value. Here there is no cross step. We don't have a cross step over here, right? So we will go with non-parametric legacy. In legacy, these are again, Raju sir will talk about this independent case, Kolmogorov, Smirnov and all, run test and all. It is a non-parametric part, but we'll go with the chi-square. Once we click on chi-square, it will show you the chi-square test pop-up. This is the menu that will pop up. Then in that case, our test variable, we want to check it is uniform. Where it is uniform? In the days. So whether it is Monday or Sunday, the variable, the number of accidents are same. So my test variable will be what? Day. Now the important part, you see the expected value. There are two options for it, expected. One, do you want all categories to be equal, or you want a specific output of expected value? So there are two options. One is categorical, that means all categories are equal, that is a uniform distribution, or it is not uniform. Not uniform means a particular distribution is given to you. So we will have to write down expected frequency accordingly. Here, what was our assumption? All categorical are equal. That means Monday or Sunday, accidents are equal. So just click on this. Once you click on this, right, you will get an answer. That easy it is. What is the answer? The chi-square value is 4.167. P value is 0.654. So my P value is 0.654, which is greater than 0.05. So H0 is accepted. That means it can be concluded that the proportion of accidents are equal in all days. Though the non-statistician, the layman will think they are not equal. Here it is 14, here it is 16, here it is 8, here it is 12. But we have taken for only 84 different accidents we have taken. For a week only we have done it. So there is bound to have these variations. But is this variations negligible? That is what chi-square says. Yes, it is negligible. So we can say that it is uniform. We'll do it in SPSS. Okay, this is what we will be doing it. Where to go for? There is no cross step over here. So go with analyze. Then in analyze, non-parametric. In legacy dialog, go in chi-square. I hope now it is clear. Whenever it is a cross tabulation, then we will go with the descriptive stats. We'll make a cross tab and we'll find out the chi-square value. Okay, I'm clicking on chi-square. There is a mistake. What is a mistake? See, what was happening? Here you can see, this is showing me a nominal variable. My accidents, it is showing a nominal variable. It should be a scale variable. This also you have to take care. That is why how to enter the data, whether it is properly entered or not, you will have to check this. What is this showing? It was showing a nominal variable. But we know that accidents are scale. So again, analyze, non-parametric, legacy, chi-square, click on this. Now it's fine. I want day over here and all categories are equal. Click on it. Okay, that is the chi-square value you are getting. This is the chi-square value that you will be getting. Okay. So we conclude that it is the same. Now the another example. where we are not talking about uniformity. We are not checking whether it is uniform or not. So what is the case over here now? Suppose it was suspected an unusual distribution in the blood groups in a patient undergoing one type of surgical procedure. It is known that the expected distribution of the population served by the hospital which performs this surgery is 44% of group A O, 45% of group A, 8% of group B, 3% of AB. See, there is always a lot of research that is going on, and one type of research, I have changed the group name. They wanted to check whether blood group AB has more number of heart attacks or more number of surgeries. So what they are doing it, they will check all the blood groups. And for 187 patients where the surgery is taken, here 67 patients where heart surgery was done, it was group O, this was group A, this was group B, and this was group A. So this is actual observed from what? From 187 patients. What was expected? That O should be 44%. O patients, O blood group patients. A group A patients should be 45 and so on. So we want to check whether the observed and expected are equal or not. Do the sample match with the expected distribution that we want to check? Again, data entering part will be the same. We'll be doing with the same part. Hypothesis, there is no difference. Okay, there is no significant difference in observed and expected. Here, that means the sample follows expected distribution. And here there is significant difference. That means sample does not follow the expected distribution. Sure. Again, this is the data. How data is to be entered? Again, the same logic. Group 1, I have labeled it categorically 167B and so on. So here I'm using the same thing. 1 is O, 2 is A, 3 is B, 4 is AB. So that is how it has been done. Yeah, O is 1. O is 1, A is 2, B is 3, and AB is 4. So that we have done it over here. What was expected? That 44% should be from group O, 45% should be from group A, 8% should be from group B. This is expected. Now, if you recollect in chi-square, now we are not talking about that it should be equal. We are talking that O should be only 45%. A should be 45%. B should be 8%. So this is what is expected. So we need expected frequency to be entered. Right? We need an expected frequency. So how to find out an expected frequency? That calculations we'll have to do it first manually and then enter in Spss. So this was observed. O is 67, A is 83, this is and so on. What is the probability given to you or percentage? 44, so it is 0.44, 0.45, 0.08, 0.03. What was this capital N? 187 patients. So 187 into 0.44, 82.28 is the expected number of patients of blood group O. 87 into 0.45, 84.15 and so on. So this is how we will find out expected frequency. And this will have to do it manually. And that depends on the probability. And this probability here it was given to you. Otherwise, based on the distribution that we are filling it, if it is binomial, we'll go with NCX, P raised to X, Q raised to N minus X. If it is Poisson, it is E raised to minus M, M raised to X upon X factorial, and so on. So any distribution can be checked whether it is equal or not. Right now, it is given to you. So we are writing down over here, and this is the expected frequency. Once you get the expected frequency, again, non-parametric, legacy, chi-square, click over here, take my decision variable. I have taken blood over here, blood group, because I want now values. I don't want that they are equal in category. Because my problem is what? I want it to be 44%, 45%, 8%, and so on. So now the values will be written. And which are the values to be written? This values. Why this values? Because this is what we are getting it. 82.28, So I've written 82.28, 84.15, so I've written 84.15, 14.96, so 14.96, 5.61, so 5.6. This is the expected value, which you have to do it manually for expected. Then chi-square automatically will, then it is not a big deal. So here, now, if I simplify things for you, there are two options. All categories are equal. That means it is uniform, in which it will assume that all are equal. Here it will assume that all are equal. Or otherwise, you will have to put the value. If you write down the value over here, then add, it will be 82.28, then the second value, and so on. Then simple. Click on that, you will get the value. My chi-square is 17.048. My p-value is 0.001, which is less than 0.05. It's less than means rejected. So there is significant difference in observed and expected distribution of the patients with respect to blood group. There is significant. So this means my data is not following the standard approved, we can say the expected value, which is right now accepted in the industry. So you can, because of this result, you can challenge the existing law. If you want to challenge something, then you should get this kind of things. Okay, that it is not coming to the same. If it is some coming, if your answer is there is no significant difference, that means nothing is new. It has already been proven first, and your data is also suggesting, okay, that is the same case, then there is no new thing that you have done it. But if you're disagreeing with the existing principle, existing theory, then we can say, okay, my data does not follow this. Then you can do it with the other sample, third sample, and then you can come up with a new research paper that the existing theory has been challenged. This is how goodness of it is done. If there are more data, how do we input? You can do it in Excel. You can do it in Excel and then select and then import the data over here. So nothing wrong in it. You can do that. Again, how to do it manually? This is, I have not done. Okay, I'll explain this also. I have not done it by my hand. I have done it in Excel. I have prepared an Excel sheet. This probability, so this will be 187. So this is 187 into this. So if you click on this and then drag, you will get all the expected frequency. But at least probability you will have to enter. Probability you need to enter. Then expected frequency will be in one click and then drag it out. You will get it in Excel. So that Excel can be utilized over here. And this is what I've done it manually just to show you actually what it happens. Actually what it happens, I'll show you. Yeah, this is OI 67, 83, 29 and 8. This is expected that we have done it 82.28 and capital N into PX have done it. Now, if you know the formula for chi-square, and many of you might have done it manually, this is OI minus EI whole square upon EI. So we'll make a column of OI minus EI whole square, right? So this is 83 minus 84.15 square of this, 29 minus 14.96 square of this, and so on. Now I'll divide this by EI. So this value divided by EI, so 233.48 divided by 82.28 and so on. This total is nothing else but your chi-square, 17.054. So this is done manually, 17.05. And if you do it manually also the same case, then for degrees of freedom, n minus 1 degrees of freedom, this is the table value that you are getting it. This is greater than this and so on. Answer will be the same. So either you do it by p-value with the softwares or you calculate it, it is the same thing. So 17.054. This is the answer. 17.048. It is almost same. Fine. So this was, I wanted to give you a flavor how it can be done manually, and or otherwise those who have done it manually, you can compare also. Okay, fine, this is the same results you are getting. Okay, Yates correction is the same thing. Oh, okay. I'll explain that also. Yates correction. See, here I was getting only chi-square value. I was getting only chi-square. If you have a 2 cross 2 table, this I said male, female, and like, unlikes kind of thing. If this is a table, and if you find out chi-square for that, there'll be one more row, continuity correction. Continuity correction. In that case, the expected frequency, here you can see all expected frequencies are greater than 5. I repeat my point again. In 2 cross 2, your taste statistics, you will be getting chi-square square also. Suppose your chi-square value is 17.048, and here you will be getting 15.547, suppose. Okay, then degrees of freedom and all that will be the same. Asymptoting p-value, whatever you are getting it. But if it is 2 cross 2, and your expected frequency is less than 5, any one expected frequency is less than 5, then you have to use continuity correction factor. But if it is 2 cross 2 and all expected frequencies are greater than 5, then use chi-square only. Because this is nothing else but Yates correction table. 2 cross 2, it should be 2 cross 2 only, not 2 categorical variable. For 2 categorical variable, there are 2 categories in each variable. Then, yeah, there was a question. Okay, what do you want, Subhasini ma'am? Okay, how p-value is calculated? If you want that, it's altogether a different and I would say a normal distribution and a chi-square distribution and all that we'll have to check for. Ultimately, what it is, p-value is nothing else but we are getting chi-square as 17 point this. So 17.048 and 17.048. This is minus 17.048. Total of these two areas in chi-square, total of these two areas is your p-value. If it is a 2-tail. But how to find out this area? We need to have a chi-square table, and then we'll say probability that chi-square is greater than 17.048 plus probability chi-square and so on. This is how p-value is calculated. But that would be, I would say, for a non-statisticians, it would be difficult to go on with a table value and check it out. But it can be done. Or else, on online p-value, if you go to Google online p-value, they will give you the p-value. You just have to enter the chi-square and click on it, they will give you the p-value. You enter the t-value, they will give you the p-value. You enter the z, they will give you the p-value. You enter f, they will give you the p-value. That also can be done. There are online platforms that give you free p-value calculations from your taste test. Okay, now coming to the Yates correction part. I hope I have answered that p-value, how it is calculated manually. And now Subhashin ma'am, you are saying about what is Yates correction here. Yates correction is used when it is a 2 cross 2 table. 2 cross 2 table. Right? In 2 cross 2, if you are okay, I'll take that example itself. This was the data. This is not a 2 cross 2, this is 2 cross 3. 2 rows and 3 columns. But by chance, assume this is 2 cross 2. This is not given to you. This is 2 cross 2. Then what you do, nothing new in it. Initially, it will be the same. Still the output you are getting it over here. Right? In the output, what you have to check? The expected frequencies. In the output, you will get an expected frequency. Here I have not taken that table, but you will get an expected frequencies. And if it is 2 cross 2, here it will be continuity correction also. You will get a value over here, you will get a p-value also over here. So if your expected frequency in the output is less than 5, expected frequency less than 5, then instead of Pearson chi-square, go with continuity correction and take that value of P. That is nothing else but Yates correction logic. Do you know what is Yates correction? What is done? If you do it manually, how it is done? I think you might have done it before. Yeah, suppose this is the expected frequency that you are getting it. Then what will be done? Here, if you multiply this cross multiply, I'm explaining it manually. So just understand. If you multiply this to, it will be 12. If you multiply this to, it will be 60. Which is less? This cross multiplication is less, 12 is less. So add 0.5 to these two values and subtract 0.5 to these two values. And then we will get a new table, which is 2.5, 9.5, 5.5, 6.5, and then we'll go further. That is actually what is done manually in Yates correction. But again, once you have a software, you don't have to do it manually. You will automatically get the answer for it. Perfect? Great. Now I still have 12 minutes. Fine. This was not a part of our planned resources. This is not a session which this should be included, but now we have 12 minutes. So I'll take something which will be useful for you. Otherwise, in the hypothesis 2, according to the initial plan, it was only chi-square. But chi-square can also be used for proportion test. So I thought, let us take this also. So that nothing is pending for you. You can do whatever test you want using the softwares. Thank you for the words of appreciation in the chat box. Okay. Now there are proportion tests. There are two: single proportion, that means for one sample, and for two samples. There are two type of proportion test, and you might have done that before, because proportion test is one of the frequently used test. And whenever there is not a scale data, whenever it is like failure, success, pass, fail, infected, not infected kind of thing, we go for a proportion test. So SPSS actually does not have a Z test. And this can be done using Z test only. But we don't have a Z test in chi-square. So we'll manipulate SPSS. What we'll do, we'll manipulate SPSS so that we get our answer. How this will be done, I'll explain now. Yeah, just remember again, this one, Z square is nothing else but chi-square. Now I'm using that particular logic. To manipulate SPSS, we should have this knowledge that Z square is nothing else but chi-square. Those who are doing it manually, this is the formula for proportion test, but it's fine. Right now, we are not going into that particular aspect. Okay. Steps will follow the same. Null hypothesis, alternative hypothesis, assumption. And what is an assumption over here? Nothing to check. This can be done by simple observations that small n into P0 should be greater than n, and small n into 1 minus P0 should also be greater than 10. If this is the condition, then we can go for a proportion test. But generally, no one checks this again. No one checks the assumption as such. Even if it is very important for T, still no one checks. Here it is not so stringent that even if it is 9 or even it is 8, we can go for it. It is not so stringent. But theoretically, yes, it should be greater than 10. Step 4, test statistics and the conclusion. So step 4 and 5 are same, whichever test you go for. Okay, let me take an example. Okay. CEO of a large water pump manufacturing company claims that What is he claiming? He claims that more than 80% of his customers are satisfied with the water pump. He is claiming that 80%, more than 80% are satisfied with his water pump. To taste the claim, the local newspaper surveyed 100 customers, and out of that, 73 were satisfied. Based on this finding, what can we say about the manufacturer's claim? So what is given? Claim of the manufacturer is what? It will be more than 80% who are satisfied. And this is percentage, so it is a proportion test. What did the newspaper wala did? He took 100 customers, and out of that 73%, so 0.73 were satisfied. This were satisfied. So this is from the sample, that 0.73. This is the population, 0.80. Is there any significant difference between these two? That is what we want to check. Now, how the data will be entered? Because there is no data over here. But still, we want to do it in using chi-square. So how this will be done? This is okay. Right. This is how the data will be entered. How many were satisfied? 73. So 73 satisfied, not satisfied are 27. This is only this much we have to enter as a data. Satisfied 73, not satisfied 27. Now we need to make SPSS understand that this means what? Satisfied, you have to write down 73 times, and not satisfied, you have to write down 27 times. Now tell me, how we will make SPSS understand that you have to take this 73 times and 27 times? We have done this before. What was the logic? What we had done it? Yes, assigning the weight. So we'll go in data. Perfect. We'll go with the weight cases. Count. So ask the computer that count the rows according to the, or frequency according to the count that you have. So that is done. So now SPSS will understand what actually our data is. Perfect. Now chi-square. So non-parametric, legacy, chi-square. Click on chi-square, you will get this table. Count. This is done. Now here again, we'll put the values. We'll put the values. Now, what was the case given to you? What was my proportion? 80%. So my 80 is favor or satisfied rather, and 20. So 80 is satisfied and 20 is not satisfied. According to the sample, according to the claim. Okay. So what was expected? I have written over here 20 and 80 over here. And if you recollect this, we have entered over here, first was 73 and second was 27. But why I have written 20 over here and 80 over here? Many of this are not taking care in this entering part, but then the whole result will be wrong. The reason is, what the software does, it will take alphabetically. And in alphabetically, N comes before S. A, B, C, D, F, I, H, A, L, M, N, O, P, Q, R, S. So N is first. So what will software do? It will take not satisfied first and satisfied second. And so because of this, I had to enter 20 first and 80 second. Getting it? So that this 80 comes against satisfied and 20 comes against not satisfied. So this care you have to take. Alphabetically, if you write down 1 and 2 over here, it won't be an issue. And then code it. But if you have not coded, take care alphabetically which will coming first, and accordingly you write down the expected frequency. Okay, that's it. Once you get an expected frequency, that's all. This is the answer. Now you have to check whether we have done it correctly or not. So the table 27, 20. Okay, that is good. 73, 80. That is good. So 27 and 20 and 73 and 80, it matches. So our table has been, SPSS has understood our data properly. My chi-square comes to 3.0. P-value is 0.08. 0.08. But this was what? One-tailed. So I have to take half. Half of this will be 0.04. 0.04 is less than 0.05. So we reject the null hypothesis. That means more than 80% of the customers are satisfied. Now, while we do it manually, we will use a Z test only. We will not use chi-square because chi-square is done in a software. We will do Z only. What is the formula we'll be using it? Z is equal to P, small p minus capital P upon root of this. Yeah, there is a question, Narayan Murthy ji. You have raised the hand. You can do that. You can do it. If you want, you can do it. But why to do that labor? Why to enter that at 80 times and so on? Because chi-square automatically does that in the count. But yeah, if you're not comfortable or if you have a fear of forgetting that weight part, it's better you do it in Excel and then repeating that columns 1,000 times or 100 times and then copy down in Excel, copy down in Spss, it would do. Fine. Sure. If I do it manually, this is how we will be doing it. We'll substitute the values, small p minus capital P. So I have substituted. My Z value comes to 1.75. Now, the logic that I was saying right in the beginning, we know Z square is nothing else but chi-square. So if you take a square, 1.75 square, just take it 1.75 square. If you have a calculator or a mobile beside, take a square, you will get roughly this value only. This is our chi-square value. So it is the same thing. It is the same thing. That is why even if SPSS was not having Z, but because of this property that we knew, we manipulated SPSS. We asked them to calculate chi-square because the answer will be the same. The p-value will be the same. So this is how chi-square can be used for. Yeah, you still have to divide. You still have to divide. If you get this Z and if you want a p-value, that p-value will be divided by 2. But generally when we do it manually, I'll just explain it. When we do it manually, we'll find out the table value only, Z table value. And for, we say 5% two-tail, it is 1 point something value will getting, and then you have to compare it. So when we do it manually, it will be Z compared to Z table value. Then there are fixed table values available. When you do it T, you have to compare with the T table value. And to avoid all this hassle, software gives you p value, so no table value is required. Directly you can compare with the alpha value and you will get the answer. Nishamani, you are saying, can we use standard deviation for, okay, for pre and post test in the master datasheet manually? See, manually you can do the whole calculation in Excel. By the way, Excel also has all this tools, data analysis tool, or it has a formula also. If you take any particular cell of Excel, put it equal to and write down STD, you will get a standard deviation. STD of what you want, then you have to select the data, you will get a standard deviation of it. So that can be done. No, this was one tail. This is two tail test. Okay, you said this will be always chi-square that we are getting it. It will be a two tail test. And so it depends. We have one tail, so we are dividing it by 2. Right. Now, if it is two proportion, just 5 minutes now. This is all. Yeah, this is a two tail. If it is two proportion test, means the sample is taken twice. Then what to do? And what is given over here? 2 brands of coffee, Starbucks and CCD, were to be compared. A sample of 100 undergraduate students were selected, and of them 50 students were given Starbucks coffee and 50 students were given CCD coffee. Coffee was served without labeling the brands. So the students were not knowing which brand it is. 42 students like the taste of Starbucks, while 45 students like the taste of CCD coffee. Is there any significant difference in the likeliness of the two brands for the undergraduate students? That is what we want to check. So this means what? We'll have the data what? Starbucks liked, disliked. Then CCD liked, disliked. In Starbucks, how many liked? 42. So that means 8 disliked. In CCD, 45 liked means 5 disliked. So this is the table that we have to prepare. So this is how the data will be entered. I'm not going in detail about null hypothesis. This is how the data is entered. Now again, we want the computer to understand that this is the weights. So we'll go for weights. Once we assign the weight, we'll go with the descriptive now because there are two categories we are having it. So we'll go in descriptive, cross tab, take coffee on one side, liking on other side, click on statistics, you'll get a chi-square. Click on that, you will get the answer. So now you see the point that I was trying to say, this is 2 cross 2. This is 2 cross 2. 2 cross 2 table. So continuity correction will come into the picture. But is the expected frequency less than 5? That you'll have to check. Is your expected frequency less than 5? That you will have to check. In SPSS output, you will get it. I have not included over here, but in SPSS output, you will get it. If SPSS gives you that expected frequency is less than 5, use this p-value. Otherwise, use this p-value. That means this is Yates correction. So if SPSS is giving you expected frequency less than 5, use this. Otherwise, you have to use this. We are not getting it right now. The output I have checked, it is not less than 5. So we'll take p is equal to 0.372. It is a two-tailed test only, so no need to divide it. So you can see the output I'm getting it is two-sided. So that is the answer for it. So this is how even proportion test, though it is not a part of SPSS, we can use this logic and find out the proportion test for it. Here also I have checked it manually. I have done it manually just to show you that if you take a square of this, you will get this answer only. And because of this logic only, instead of z-test, we have used chi-square test. Okay. I hope this is clear. Yeah, Prakashji. Yes, Subhashini, your question. Okay, no question. Fine.
Shall we finish
Achha,
this
can't
session?
unmute. Okay.
Can't unmute. They have posted the question, sir.
Ranjit Kumar, the R value that the recently newspaper are giving it is not related to the correlation or something. That is all scientific term of R value. That R value is decreasing. Probably you are talking about that article in recently Times of India. They were saying that R value are decreasing here. But that is scientific term. I have not gone into the detail, so I'll not be able to answer it what actually it is, but it is scientific term, medical term rather. Can we give satisfied and not satisfied as A and B if it has a alphabetically? Yeah, you can give it, not an issue. But otherwise, why we are not doing it that A and B and so on? Because once you get output, and that output you're using 6 months after that, then what will happen? It will be difficult for you to recollect what was A and what was B. So it is always better to label it in such a way that across time, whenever you use it, it will be simple for you and simple for others to interpret. Acha, the assumptions, how it is done, as I said, it is small n into p. It should be greater than 10. So here, what was the sample size taken? In the case of CCD, what was the sample size? Sample size was 50. 50 was there? Yeah, 50 was there. So 50 into, what was the proportion of liked? 50 into, what was the proportion of like? I think 42 liked it. So 42 means 0.84. Proportion is 0.84. So take 0.84 into 0.84 into 50. And same way 0.16 into 50. This should be 5 or more than 5 or 10 more than 10. That is how it is checked. Okay. I have exceeded my time by 7 minutes, but I have included one extra point, that is proportion test, which was not a part of SPSS, but we can use that logic. So I thought now your data, because I've seen majority of the researchers have proportion test in their research, so that will be useful. Yeah, I'll have to take correlation regression at a later stage. Probably on Saturday, I have my session. So on Saturday, we'll be taking with correlation and regression, and that will be my last session for the workshop. Okay, so I'm done with my presentation, ma'am, and there are no questions right now.
Okay, sir.
Okay, sir. Okay, sir. Pravina, are you here, ma'am?
Yes.
Pravina,
Your video is off, Pravina, ma'am.
We can't hear you. Please be louder.
Today,
I will.
are you able to hear?
Yes, madam. Madam, Saila madam, voice is breaking.
Associate Professor, Department of Education, to propose. Be louder.
Actually, from the chat box, I could infer that regarding the comments about sir's lecture, very good information. Super, sir. Thank you, sir, for your clear explanation. Very useful session. Excellent, resourceful professor. Really very useful for us. Very nice session, sir. Very interesting and informative, enlightening. Sir, we also endorse the same thing on behalf of the organizers. We are really happy, sir, that you have spent your valuable time with us today dealing with chi-square test with the 3 types: the goodness of fit, association, 2-scale variable, and significant sample variance. Everything with example you have explained, and our participants are highly benefited, sir. And they are very happy because they say enlightening, excellent, resourceful professor. We are also very happy that we are able to get you onto the line. Thank you, sir. We'll be meeting you again on 29th for regression and correlation. Thank you very much on behalf of IQAC, sir.
Thanks a lot. Thank you. Thank you,
Thank you,
Pravina,
sir.
ma'am, for the nice words. Thank you, Shailina, ma'am.
Thank you,
And
sir.
bye. And bye, all the participants.
Thank you, sir.
Thank you.
Thank you, madam.
Thanks, Epti.
Madam, thank you, madam.